Now, after looking at the upper level maps, what I want you to do is still stay with the GFS, but I want you to click on national, and you can click on continental United States, and you have to change the parameter on the left hand side, surface and precipitation, and I want you to click on precip type and rate. And here what you can see is you can see the dashed lines which indicate 500 millibar height, so you can actually see your bias. You can actually see what's going on with the jet stream, but you can also see where all your areas of high and low pressure are. Okay, so now here we are. Here we go into Friday. Here, 2 high pressure system cells. Okay, one back a little bit west towards the Great Lakes, and then one centered right over New England. So as we move forward in time, right, this high pressure system, okay, starts to move off. The one that's back out in the Midwest weakens a little bit, and then you have a little weak wave. Remember that we discussed this previously. We have a little weak wave that passes through Pennsylvania, New Jersey, okay, and basically just kind of fizzles out and doesn't really become anything, all right? So it's really just a weak wave. Now this area of high pressure, remember, high pressure causes subsidence, so this causes air to sink. High pressure pushes air down onto the surface. So if you notice that it looks like this weak wave of low pressure starts to get going, but this high pressure system way up in through southern New England, or centered right over southern New England, really keeps this at bay and pretty much keeps the air dry, so this low pressure system down through here pretty much just fizzles out. Now what's interesting is that here's your second weak wave, and here's the other weak wave that we talked about that we wanted to look at for Saturday, okay? Now look at the timestamp, okay? Friday, March 1st, 18Z. Now we're still relatively calm, okay? But high pressure starts to move offshore. What does that do? If high pressure moves offshore, that allows a low pressure system to move into our region. And based on where the jet stream winds are, it makes sense that this low is going to traverse or track just south of New England. Now look, here's Saturday, 9Z, 4 o'clock in the morning. You can see how snow is developing, or has developed. Even a couple hours before that, snow has developed into southwestern Connecticut, southern Connecticut, Rhode Island, and even into southernmost parts of Massachusetts, and including Cape Cod. So now by 12 Zulu, by 7 a.m., it looks like it's been snowing pretty decently over the last 3 hours, okay? Now remember, these timestamps show what the atmosphere has done in the previous 3 hours. So don't be confused. So by 12Z, it looks like the time between 4Z and 12Z, you see how the blues in here got darker? That means that precipitation has actually increased from 4 a.m. to 7 a.m. So now it's snowing a little bit harder as this low pressure system develops. So see here, it was a 1014 millibar low. But now as it's gone over warm water and we have cold air, what have we learned about warm air versus cold air? Well, warm air and cold air, they don't like each other. When you have a difference in temperature like that, you have big differences in atmospheric stability. And so what does that mean is that you can develop deeper areas of low pressure, which means you can have stronger storms. In theory, it doesn't always happen like that. But in this case, that's exactly what's happening. The low goes over the warm water, intensifies, picks up more moisture, and then drops it right over southern New England. And actually gets very, very close, according to the GFS model, gets very close and drops a decent amount of snow for the first part of Saturday. And then by Saturday afternoon, it looks to basically scour out, although according to the GFS, by 18 Zulu, it looks to stick around a little bit more, and then basically taper off to light snow showers through the evening time, and even still go on as some light snow showers through about midnight on Saturday. And that's what's going on for Saturday's system. And then here is Monday's system, and this one looks to pack even a greater punch to southern New England and into Boston. So this will be something to watch as the days come. Remember that models get a little bit better the closer you are to the event. So that's what it looks like from a CONUS point of view. So when you look at your regional United States, and we click on the Northeast, and if you're forecasting for anywhere in the Northeast, you can use the same view. So now we move forward, right? And we can see how Friday is dry, but here we go Saturday by early morning, by 4 o'clock in the morning. Now it's starting to snow in southern Connecticut, Rhode Island, Massachusetts, like we showed before. And you can really get a better picture and you can see better what's going on down here or more regionally for the area that you're forecasting for. So this becomes very, very important. Now that's the GFS's view on things. I want you to look at the GFS, okay? And I also want you to look at the NAM, okay? Now you can dabble with some of these other parameters, okay? Like this GDPS, this is the Canadian model. This is the Canadian's version of the GFS. You can look at that for what it is if you really want to look at it, okay? The NAM is a more regional model. But what's also really nice and what you have access to is the NAM 3 kilometer. It's more high resolution than the traditional NAM. I actually like using the NAM 3 kilometer a lot, especially when I'm in a 48-hour window. And that is pretty good for Saturday's system. So here, right, this is Friday, and it shows that little blip of moisture, okay, coming down through the south coast. And what's great about Pivotal Weather is that you can click on these soundings, and you can see the sounding here, all right? So yeah, it does show snow, but look at the difference between dew point and temperature. It's about a 10-point depression. So the air is a little bit dry. So if this does fall as snow, it's going to fall as light fluffy snow because the air is a little bit drier, similar to what Boston had earlier today. But it doesn't necessarily look to show much. So let's move through time a little bit more. And now look, the NAM is a little bit different. The NAM keeps this low further south, whereas the GFS had it a little bit closer up. What I would do is I would open up a new tab here. And if you really wanted to look at the differences between the two, you could do this and move things forward. Here we go. So this is 15Z on Saturday. This is 15Z on Saturday according to the NAM. You can see the model differences. Look at these. The GFS is way slower. It produces a stronger area of low pressure, and it produces more precipitation, whereas the NAM does not. The NAM is faster and doesn't produce as much precipitation as the GFS does. Okay? It actually keeps the precip shield very concentrated in southeast Massachusetts and only brings a little bit up into Boston, whereas the GFS brings more snow widespread throughout southern New England and would bring more precipitation or more snowfall into the Boston area. So this is how you decipher between the two models. Which one is right, you'll have to wait over the next few days. Or unless you feel that one model has been performing better than the other model, then you can use that information as well. So here we have snow coming in for the next 2 days. So you could write that down. So you know that you're going to include snow on Saturday if you were forecasting for Boston in this example. Okay? So where do you go from there? Well, like I said, I like to use the NAM because it's built for more higher resolution for systems like this at a closer time scale. So if I wanted to look at how much snow I was getting, I would want to go to winter weather, and I would want to go on total accumulated snowfall, and I want to click on the Kuchera. What is that? The Kuchera basically just means is that it takes the maximum temperature in the atmospheric profile, whereas the 10-to-1 basically just shows you how much snow has fallen if it was a 10-to-1 ratio. I always like using Kuchera because snowfall is not always at a 10-to-1. Sometimes it's an 8-to-1. Sometimes it's a 30-to-1. It really just depends. So if you use Kuchera, you're pretty much safe. So let's move this forward. We really have nothing on Friday, but now here's Saturday. So now look, Boston looks to get about 2 to 4 inches. Southern Massachusetts, and including the Cape, they get 5 to 7 throughout Saturday morning, according to the NAM model, the 3-kilometer NAM model. The GFS, if we do the same thing, winter weather, total accumulated snowfall, and we move it forward through time. Now you can see, look how much snowfall now. Now we're talking a whole lot of snowfall. So now we're talking, quite a plowable event. 8 inches, 9 inches, 11 inches down in through central Connecticut. 6 inches in Boston, 5 to 6 inches in Boston. So this is a much more significant event for Saturday, and that's actually really significant, and it's very, very interesting. So what you could also do is you could open up another tab and let's see how the operational NAM model. So we use the 3-kilometer NAM, but what about just the NAM model itself? let's do the same thing. Let's move this through time and let's see what it says. Well, the NAM, you can see that the NAM is even less than the 3 kilometer NAM. So see how forecasting gets a little bit more difficult. Now you have differences in the models. You have discrepancies in the models, okay? Because they all are looking at the atmosphere differently because they're all built differently. They all have different opinions. Just like meteorologists can all look at the same map and have different opinions about the forecast. So this is something that is going to be developing over the next couple of days, but it is something to watch. But I know that it seems as though all 3 models, both versions of the NAM and the GFS, have both signaled some kind of snowfall for Saturday, especially for southeastern Mass, Connecticut and Rhode Island, and even into Boston. So this is something that I would want to watch. And if all 3 of these models are signaling that there's going to be snow, chances are it's a pretty good signal that we're going to get something. I don't know how much, but it looks like we're going to get something, okay? So now that we figured out what the weather overall is going to be, how do we figure out temperatures? Okay, now remember, there's multiple ways that you can figure out temperatures. You can use, I'm just going to use the NAM 3 kilometer for this. If you want to use the temperature plot on pivotal weather or by pivotal weather, you have to click on surface and precipitation. You can either click on 2 meter HEL, which stands for above ground level temperature, or you could use 2 meter above ground level temperature and wind barbs. I like this the best because you can look at the winds and you can look at the temperatures at the exact same time. All right. So here's temperature. And again, if you just roll over, the cursor shows you what the temperature is. So you can roll over in time. Now here's Friday at 12Z. Friday at 12Z, that's 7 a.m. What's the temperature in Boston? 22. Now what does the GFS say? Let's do the same thing. Precip. 2 meter temperature and wind barbs. Move forward. And 12Z. Okay. 21. Okay, so pretty close. 21, 22 degrees. So below freezing in Boston for the first thing tomorrow morning. Okay, good to know. So that's pretty simple. Both models are in agreement. That's good. So now let's move forward a little bit. 18Z, 21Z. By 18Z to 21Z for this time of year, that's pretty much when you're going to experience your high temperature for the day because it's right around 2, 3 o'clock. So here we have a max temp of about 35. If we go to 18Z, it's about 33. So let's say 34 for a high in Boston for tomorrow, Friday. And the GFS pretty much agrees with this, 35, 36. So let's say 35 for a high in Boston. So I would write that down. So a low of, let's say, 22 and a high of 35. All right, cool. So I can use this, right? But if I wanted to get more technical, I could just use MOS, right? And MOS is going to take a little bit to load. But here, you click on the state, Mass, you click on Boston, go to the bottom, you hit Submit, and hopefully it doesn't take too long. And there we go. So here we have 19 for, according to MOS, or according to the GFS MOS, we have 19 for a low on Friday, 20 for a low according to the NAM. So that's pretty close. So you could say, 19 to 21. You could pick a number in between that. You could take an average. You could say, 20 for a low or 21 for a low. 35 for a high according to the GFS MOS. 34 for a high according to the NAM MOS. So let's use 35 because I'm trying to rush the season a little bit. So let's say 35. 27 for a morning low on Saturday. 27 for a morning low on Saturday. Now remember, with MOS, look, you can use the precipitation categories, right? So precip in a 6-hour interval, here you have 0.1 and 0.3, right? Or category 1 and category 3. So the category 3 almost brings it up, if you believe the GFS, brings it up to almost a half an inch. And in snowfall terms, if you believe the 10 to 1, that's at least 5 inches of snow as a category 3. But down here, if you believe the NAM model, remember the NAM was significantly less. Here it only shows a category 1. And if you put these two together, they're a category 2, which is about 1/4 of an inch of liquid precip at the 10 to 1 ratio is about 2.5 inches. So we can say about 2 to 4 inches for Boston if we believe the NAM. And I'm a little bit more inclined to believe the NAM just because it's a little bit more accurate and a little bit more reliable 48 hours out than the GFS. The GFS handles longer term trends, better. But when you're trying to look at the smaller details, as in like how much snow will fall, the NAM tends to be a little bit better at this, okay? But this is how you use different models to compare, okay? Now for winds, right, we can look at the winds here in Boston, right, on a pivotal weather site. You can see how all these wind barbs are coming in from the south, and they're very light, okay? Now this is a little bit hard to see, so you could use the wind speed from the NAM model and use, as you can see here, it's for tomorrow. We're looking at, 5 knots of wind, 2, 3, so very light, so anywhere between 5 to 10 miles per hour of wind. When we look at wind direction, this WDR, look, everything's coming out of, 340, 300, 330, 320. Okay, so this is basically a northern wind. 360 or 0 would be the north. So this is about north-northwest. And then as we go through later on in the day, these winds shift from the north and then they become directly south. Look, 180, 18, 18, these are all 180-degree winds, so that's from the south. And then it goes 120 degrees, so that's southeast, and then it goes a little bit, east-southeasterly from there on out. That's according to the GFS, and that makes sense because the GFS showed that low to be coming a little bit closer to the coast of southern New England. But if you look at the NAM model, you can see here, yes, the winds come from the north, and then they go a little bit more southerly, yes, but they kind of stay southerly, and they don't necessarily go east, southeast, all right? Don't be so concerned on the winds. Just try your best, and I would definitely be more lenient on the NAM model for the winds because, again, the NAM is a little bit more high resolution. And if you want to be really accurate with the winds, MOS is the way to go because, remember, MOS uses linear regression to account for error. So as time goes forward, you can see how the winds get a little bit more accurate, or the model itself gets a little bit more accurate. And if you don't necessarily like that version, you can just go to the National Weather Service website at weather.gov. You can put in your location, Boston, hit go, and you can use the grids, hourly weather forecasts. So if you just wanted to look at wind, you could just look at surface wind, and you can uncheck the rest of these if you really wanted to, and you can hit submit, and you can change the period, and look, you would just get winds, okay? And it tells you it shows you where the wind direction is coming from. So this is coming out of the northeast, and then again they go southerly, and then they go a little bit more east, okay? And here you can see the wind speeds are just fairly light throughout a 48-hour period, okay? So that's how you would figure out winds, and they also give you snow totals as well. So here's 0.2, 0.6, 1.6, 0.6, 0.6 again, okay? So this is Saturday, and it goes all the way to 6 p.m. So you could just take your calculator if you really wanted to and say 0.2 plus 0.6 plus 1.6 plus 0.6 plus 0.6, okay, equals to about 3.6. So this looks to be a little bit closer to the NAM solution. So that's why I wanted to lean a little bit more on the NAM, just because it does seem like the GFS is just a little bit more overdone. And again, I'm a meteorologist, so I've seen this system happen so many times, and it just gets downplayed a little bit. And that's just because of my experience. But in your forecast, you ultimately have to pick one or the other. If you decide to blend both models, tell me. But you can choose any model preference that you like. But I do want you to have a variety of different sources of weather and weather models when you make your forecast. And again, you're going to forecast for the 3 days. You're going to tell me the high and low temperature, precipitation. You're going to get the start and stop times. And that's why I say it's very important to understand Zulu time. You have to understand Zulu time for when these things start and stop. So that's how I want you to set up your forecast. I know this video was a little bit lengthy, but I hope you found this useful. And if you have any questions, please feel free to let me know.